Hello students, welcome back to the revision class of the chapter Light, Reflection and Refraction. Now we begin with the image formation by spherical mirrors. So in this part, we will discuss how images are formed by spherical mirrors. We start with concave mirror. We try to understand the image formation by a concave mirror for the objects that are placed at different distances through a simple activity. So for that, you take a table and draw a straight line on it and place the concave mirror with the help of a stand and mark the pole of the concave mirror, say it is P. Now we need to choose an object to find out the focal length of the given concave mirror. It can be a building or a tree that is at a distance, say some 100 to 200 meters. We have chosen a tree and we need to get the image of this tree onto the screen. For that, you need to place a screen in front of the concave mirror. Now move the screen back and forth until you get a clear image of the tree on the screen. Once you get the clear image of the tree, you note down the position of the screen. Then this will be the principal focus of the concave mirror, that is capital F. The distance between the capital F, that is the principal focus, and capital P, that is the pole. So it is the focal length of the concave mirror. Now you measure the distance that is twice that of the focal length and then mark the position that will be the center of curvature of the concave mirror. Therefore, the distance between C and P, that is 2F. Now we note down these observations in a table. So for that, we draw a table and then make the columns for the observations of position of the object, position of the image, and the size of the image and the nature of the image. So the position of the object, that is the position of the tree, that is taken as infinity. Therefore, it is taken at infinity, and the position of the image, that is formed at the principal focus of the concave mirror, so it is capital F. The size of the image when compared to that of the object, it is very small, therefore it is highly diminished. And the nature of the image, it must be real because the image is caught on the screen and it is inverted one, therefore it is real and inverted. Now we take some smaller objects, say it is a candle which is lit, to place it in front of the concave mirror at finite distances. The first position, say it is placed at some position beyond C, and for this position of the candle we get the image on the screen that is placed in between C and F, and the size of the image, it is small when compared to that of the object and it is inverted one. Therefore we note down the observations. So when the object is placed at C, then the image is formed in between F and C and it is diminished image, and nature of the image is real and inverted. Now we move the candle toward the concave mirror such that it is placed at the center of curvature of the concave mirror, that is C. Now for this position of the object, surprisingly we get the image at the same position, that is the C, and the size of the image is same as that of the object. So we note down the observations in the table. The position of the object is at the center of curvature, that is C, and the position of the image is also same, that is C, and the size of the image is same as that of the object, and the nature of the image is real and inverted. Now we move the candle further and we place it in between C and F, and for this position of the candle we get the image on the screen that is placed beyond C, and if we compare the size of the image with that of the object, it is slightly bigger. Therefore we note down the observations here. Therefore the object position is in between F and C and the position of the image is beyond C, and the size of the image is magnified or enlarged, and the nature of the image is real and inverted. Now we move the candle towards the concave mirror and we place it at the principal focus of the concave mirror. Now for this position, we don't get either the real image or the virtual image. The reason is the rays which are coming from the candle, they will go parallel after reflection. Therefore they will meet at infinity. Therefore the image will be formed at infinity. So we cannot find the image on the screen, that is the real image, or we don't find any virtual image. Therefore for this step, the observations are the object position at F and the image position is at infinity, and we cannot find any image to find the size or the nature of the image. Next we move the object further and we place it in between F and P, and for this position of the object we find the image that is behind the mirror, therefore it is virtual image. And if you compare the sizes, the size of the image is slightly bigger than that of the object. So we note down the observations. The position of the object is in between F and P and the position of the image is behind the mirror, and the size of the object is magnified or enlarged one, and it is virtual image erected. So these are all the observations from the simple activity, and from these observations we can note down some important points for the images found by the concave mirrors. And these important points are: the first one, a concave mirror forms both real and virtual images. We have seen that when the object is in between infinity to the principal focus, we have seen that the image is formed on the screen. Therefore, it is a real image. And when the object is before the principal focus, the image is found behind the mirror. Therefore, it is the virtual image. And next one, the real image is always inverted and the virtual image is always erected one. We have seen in the activity that whenever the real image is formed on the screen, it is always inverted one. And when the virtual image is formed behind the mirror, that is erected. Next point, as an object approaches the concave mirror, the real image formed moves away from the mirror but not proportionately. So we have seen this one in the activity that when the candle is moving towards the concave mirror, the image of the candle formed on the screen is moving away from the concave mirror. The size of the image is always increasing even though the size of the object remains the same. The next point, if the object is placed at C of the concave mirror, then the image will also formed at C and the size of the image will be same as that of the object. Yes, we have seen that when the candle is placed at C, the image is also formed at C and it is of same size as that of the candle. And last one, virtual images formed by concave mirrors are always magnified. When the candle is before the principal focus, the image formed behind the mirror is the virtual one and it is erected and it is magnified one. These are all the important points from the activity done by using the concave mirror. In the previous activity, we have seen that images of different sizes and different natures are formed when an object is placed at different positions in front of a concave mirror. Now we will represent these image formations using ray diagrams, and for drawing ray diagrams we generally use 4 types of rays. Although an infinite number of rays can come from an object, only 4 standard rays are considered to construct ray diagrams. Among those, we use at least 2 rays to locate the point where they intersect or appear to intersect. That point gives the position of the image. These 4 types of rays are also called the rules for constructing a ray diagram. We see one by one. The first one, so if the rays are traveling parallel to the principal axis and incident on a concave mirror, then after reflection they pass through the principal focus of the concave mirror. And if you draw a normal, that is the line joining the center of curvature and the point where the light ray is incident, that is called the normal. And the angle between the incident ray and the normal angle of incidence, say it is I, and the angle between the reflected ray and the normal, that is say it is R, and these 2 angles are equal according to the first law of reflection. If the same light ray that is parallel to the principal axis incident on a convex mirror, then after reflection it appears to diverge from the principal focus of the concave mirror. If you extend the reflected ray in the backward direction, then it meets the principal focus of the convex mirror. And here, if you draw the normal, that is the line passing through the center of curvature and the point where the light ray incident, we can show that angle of incidence, that is I, and the angle between the reflected ray and the normal, that is R. So these 2 angles are equal according to the first law of reflection. So here we can conclude that if a light ray, if it is traveling parallel to the principal axis and after reflection it either passes through the principal focus, that is in the case of a concave mirror, or it appears to diverge from the principal focus, that is in the case of a convex mirror. Now we go for the second light ray. So in this case, if the light ray is passing through the principal focus initially, then after reflection it goes parallel to the principal axis. And in the case of the convex mirror, if a light ray appears to pass through the principal focus of a convex mirror, then after reflection it goes parallel to the principal axis. And here the conclusion will be, so if a light ray initially passes through or appears to pass through the principal focus of a spherical mirror, after reflection they travel parallel to the principal axis. Next rule, so if a light ray, if it is passing through the center of curvature and incident on the reflecting surface of a concave mirror, then after reflection it goes back in the same path. That means it retraces its path. The reason is the light ray incidents normally on the surface if it passes through the center of curvature initially. If a light ray appears to pass through the center of curvature of convex mirror, Then after reflection, it retraces its path. That means it goes back in the same path. So we can give the conclusion that if a light ray incident normally on a mirror, so it gets reflected normally and retraces its path. Next one, the fourth ray, a light ray incident obliquely at the pole of a concave mirror, then it reflects in such a way that the angle of reflection is equal to the angle of incidence because it follows the laws of reflection. So in the case of a convex mirror, so if the light ray incident at the pole of the convex mirror, then it reflects such that the angle of incidence is equal to the angle of reflection. So we can give the conclusion that if a light ray incident obliquely at the pole of a spherical mirror, that is either the concave mirror or the convex mirror, it reflects from the pole such that the angle of incidence is equal to the angle of reflection. So these are the four rules that help us to construct ray diagrams and determine the position, size and nature of the images found by spherical mirrors. Now we draw the ray diagrams to understand how a concave mirror forms images when the object is placed at different positions in front of it. So first we draw the concave mirror and we mark the pole of the mirror, that is P, and the center of curvature of the mirror, that is C, and the line passing through these 2 points is the principal axis, and we consider the object which is at infinity and the rays are coming from infinite distance. They are parallel to the principal axis, and we consider two such rays, and these two rays incident on the reflecting surface of the concave mirror, and after reflection they pass to the principal focus of the concave mirror, that is the image is formed at the principal focus of the concave mirror. And here we note down these points, so that is the object is at infinity and the image is formed at the principal focus, and the image is real, inverted, highly diminished. The next one, we consider the object that is beyond C, and we take two rays that are coming from the object. One is the ray that is parallel to the principal axis, and second ray is passing through the principal focus of the concave mirror. So the first ray, after reflection, it has to go through the principal focus, and the second ray travels parallel to the principal axis. So these two rays meet at certain point in between C and F. So this point is the image point for the object point, that is here. So therefore we can take infinite number of points on the object. For those points, if you consider these two types of rays and draw all the image points and then you connect them, then you will get the image, that is the inverted one. So we note down these things, that is the position of the object is beyond C and the image is formed between F and C, and it is real, inverted and diminished one. Next, we move the object towards the concave mirror, that is we place it at the center of curvature. Again we consider two rays from the object. One is parallel to the principal axis, the second one is passing through the principal focus. The first ray, after reflection, it goes through the principal focus, and second ray, after reflection, it goes parallel to the principal axis. Therefore, they will meet at a distance that is equal to center of curvature. So we get the image, that is inverted one, real, and it is of same size. So we note down all these things. So here the object position at C and the image position is also at C, and the image is real, inverted, and it is of same size as that of the object. Now we move the object further and we place it in between C and F. Again we consider two rays from the object, that is one is the parallel to the principal axis, the second one is passing through the principal focus. So after reflection, the first one goes through the principal focus and the second one goes parallel to the principal axis. So these two rays, they will meet beyond C. Therefore we get the image, that is inverted, real and bigger in size when compared to the size of the object. So we note down these points. So here the object position is in between C and F and the image is formed beyond C and the image is real, inverted, magnified. So we move the object further and we place it at the principal focus of the concave mirror. And we take two rays. So one ray is passing parallel to the principal axis and the second ray, it appears to coming from the center of curvature of the concave mirror. So after reflection, the first ray, so it goes through the principal focus of the concave mirror. The second ray, it retraces its path, that means it goes back in the same direction. And if you observe these two rays, they are parallel after reflection. Therefore, the image cannot be caught, as well as if you extend these two rays behind the mirror, again they will go parallel. Therefore, we cannot get either the real image or the virtual image. So in this case, The object is at the principal focus and the image is formed at infinity. We assume that the image that is formed at infinity is a real, inverted and highly magnified. And we move the object further and we place it before the principal focus of the concave mirror. And again we take two rays. One is parallel to the principal axis and the second ray that appears comes from the center of curvature of the concave mirror. So after reflection, the first ray it passes through the principal focus and second ray it passes through the center of curvature. So if you extend these rays behind the mirror, they will meet at a point. That means the image of the object is formed behind the mirror, therefore it is a virtual image. And if you observe the size of the image, it is bigger than that of the object. Therefore, in this case, when the object is placed between F and P, the image is formed behind the mirror and this image is virtual, erect and magnified. Uses of concave mirrors. Concave mirrors are used in torches, searchlights and vehicle headlights to produce powerful parallel beams of light. They are used as shaving or makeup mirrors to see larger image of the face. Dentists use concave mirrors to get an enlarged view of a patient's teeth. Large concave mirrors are used in solar furnaces to focus sunlight and produce heat. Thank you for watching the video. If you find the video helpful, please like, comment and share with others.